slide for you too. So with your partners at your table, you're going to create an initial model. This model is just to get your first ideas out on paper, so we're not looking for correct answers here. You'll make it more accurate later. But for right now, there's not really a lot of limitations to how you can represent what's happening inside of that car. But there's two things that we're asking for here. Talk together and agree on some things maybe before anyone starts talking at your group. So if it helps you, before you start drawing, maybe talk out loud. If you'd rather just kind of sit by yourself for a few minutes and brainstorm your ideas, you can. But again, you're doing a before, during, after. Maybe the easiest way to set that up on your paper is to have 3 blocks. Maybe you're going to do a flow chart. That's your decision to make. Draw and label with words what you can see and what you think might be happening that is unobservable. Before crushing, during crushing, and after crushing. Here are some conventions you can use if you're unsure of how you might like to start. You can, for example, if you want to talk about air particles, you can represent them by dots and talk about how those air particles move using arrows. Try to illustrate both what you could see and try to guess what you couldn't see. What was happening that you can't necessarily see just by looking at that. Once everyone in your group has had a chance to develop a model, start talking about your models, and as a group, put a group model on half of that sheet of poster paper that you were given. So you might take parts from everybody's, maybe you take more of one person's. That's for you guys as a group to decide. inside of that car. Take parts of your images, combine it with others, and see what you can come up with for a group model.
It's okay if you don't know. This is an initial model that will refine.
Look at the comparison. We can bring back the fact that you like did that part diagram in that one.
Yeah, but I was
That
like,
you
if
drew
they would
out.
do that part.
You get better at drawing those. I think we like drawing this out.
And if you would, label this with like initial or drawing number 1 or something like that.
I didn't mind this like starting and sure didn't want to.
I just realized that we're doing my modeling activity next week, and it's with like something that will be Halloween. And next week is Halloween, and I just realized that, and I was like, I got excited.
Police costume. Well, I have to make it, but I have to make like I like what they understand. Yeah, it really does. Because you're way better at it, believe us.
So then do you think for the during phase, you should focus more on the observable or unobservable? If what you're saying is you're having a hard time figuring out what during versus after would look like, do you think you should focus more on what's happening that you can physically see or what you can't really see? Yeah, so maybe you spend a little bit more time on that middle diagram if you feel pretty good with
Where it's like halfway crushed.
before. That's what mine would look like.
Yeah, so it like looks even.
Yeah.
Just wondering, do the number of air particles, or are these dots, what do they represent for you?
General air particles, the number of lemons.
So it doesn't matter then if you're before S4 and, okay.
Yeah, they're, I think I have their up to that.
Yeah.
Gotcha. Okay, so the direction is more important to you than the number. Cool. Do me a favor, just while they're finishing up, maybe try to write a few like words to explain what's happening in each one, just very brief, the best you can.
Why you're doing it, we want you to do this.
before we move on, I want you to do, I want you to consider a question for me. You'll take just a minute or two, discuss at your table, and then each table will share out one or two ideas. Talk at your table for a second and think about what questions are still puzzling you about this. So think about what were some of the obstacles you encountered when trying to come up with this model. Maybe, is there something you feel like you should know more about, something you want to know more about? Is there something that you feel like is missing, and if so, what is that? So take a minute or two, talk at your tables, and then each table will share out at least one idea.
That's how mine is too. Yeah.
Or just a thing.
Yeah. I think that the middle just is stays crushed, but I don't really know.
All right. Katie, would you, your group, mind sharing out one of your ideas that you talked about?
About what?
Uh,
I still have questions about?
Yeah, like maybe what were some of the questions or something you felt like was missing that you still don't know yet?
Well, like one thing that we kind of like struggled with is like we have a little bit of different models where like at the beginning of me and Leanna's it's big, and then in the middle it's like kind of halfway crushed, and then it's all the way crushed at the end. But like Maya's is crushed in the middle, like during the during part, so we're just like what constitutes middle during.
Okay, yeah. What exactly would it actually look like in the during crushing phase? Interesting. I think that's interesting that you guys are thinking about that. Like, how should it be best represented? I think that's interesting. This table up here, what's one idea? Like maybe why it was there, how it formed the vacuum of being sealed off, stuff like that. Okay, yeah, perfect. So these are all really good questions, and ideally, after you kind of move through this activity, you'll kind of be exposed to some of the concepts that might help you readdress some of these puzzling topics that you just mentioned. So before we kind of dive into the meat of this activity and this model, what it's representing, we're going to create our own model of the video that we just saw. So we're going to create our own model of a tanker car crushing, right? So you have something a little bit more concrete to build off of, and then you're going to spend a little bit more time digging into some of the content. So what is actually causing that to happen? And then we'll come back and revise our models. And throughout that whole process, I think what's important here is you'll have the demo beforehand, so that while you go through the actual content, you can start connecting it to the model, and then you can connect it back to the actual training. Does that make sense? So here's what we're going to do. You're going to divide up into two groups of three. There's a station over here and a station over here. All of your materials are there. At that station, you'll take your graduated cylinder. You will measure out 20 milliliters of water, and you're going to pour that into one of your empty cans. You'll put that can onto the hot plate until that water starts to boil. When that water boils, you'll allow it to do so for 1 minute. Then you will carefully remove your can off of your hot plate. Both groups have tongs. You'll take those tongs when you're doing so, because you don't want to burn your hand, and you're going to flip the can upside down into the tub of ice as quickly as you can with that boiling water in it. And then you're going to observe what happens, okay? If you have questions, just check out these instructions up here. But go ahead and head over to one of these two groups. And the hot plates have been on for a few minutes, so it should be close enough to where we can start boiling. I don't think so. Yeah, I don't think so. We could stretch it out though. I mean, I'm sure.
Just in case.
Is it really hot underneath?
Really squash it?
Yeah, it is.
Did you put it in the soda can?
Or if we had another thing, tongs maybe?
They're
Assorted sizes.
they're like actual like
Let's work.
yeah.
Oh, really? Oh, because you problem solvers.
You're a pro.
Okay, now we know for sure.
I just don't know.
Oh.
I think I would have probably
Did this, I don't remember anything. But they like heat up one of the big blue water, like giant blue tubs,
Mm-hmm.
and then like sealed it off, and then sprayed it with a hose, and it colors.
Gotcha.
So it's the same basic concept.
So the initials, yeah, so there's a story, I don't know, that this was a recreation of them trying to find out that a bunch of train yard people showed up to work the next day and they found a train car crushed like this and they were like, what happened?
No, I didn't know that.
And so they came up with ideas as to how it got like that, and then this was testing one of those ideas, the video that you see.
Mythbusters has done it too.
Yeah, Mythbusters. I knew.
They had to like break the car to get it to do it.
They-
They
yeah.
had to like bust it basically
Oh.
to get it to actually collapse on itself.
And I'm sure it
I don't
totally
know how
matters
they
like
were
what
doing it,
it's
though.
made of.
Like what the material
Yeah.
is. Yeah.
They like have to like yeah, they have to like damage the structure of it. To get it to It is.
You can hear, I hear like one little like bubble.
It's not gonna kill it.
If you're having maybe mac and cheese and bites, it looks like it's bubbling.
And you can heat it more than one at a time if you want to, like it boils for like a couple seconds beyond that first one.
Yeah.
That other thing. And we have loads of cans. I paid my kid $1 a can to go take it to my recycle bin and get these out. So that's why we have so many.
That $1 a can, that's a
That's
lot.
really good. I know, you got $20 out of it.
25 cents to get those little gumballs out of the yard. Like
Wait,
every
actually?
Oh yeah.
25 cents a gumball.
What's really clean?
It is kind of it's not even like paying attention to those.
I want to take a video of it.
Yeah. I have to make a shirt today that says EpiPen because school is gonna be EpiPen. I'm gonna be a bee. I'm allergic to bees.
I'm allergic to bees too. I guess that.
My dog's gonna be a bee too. I'm taking her to the party with us.
I didn't know that my friends were having parties like this weekend, so now I have to make shirts with the correct costume. Probably the next 2 days.
Like a little spider. My costume is like the same, it's just a different color.
I love Halloween. My roommates and I went all out last year for a Halloween party. Halloween and Christmas are my two favorites.
Halloween. And
Oh, I
I'm
like
married to like a Halloween screw.
I have wings and I'm gonna like pull my hair and put it like up. Yeah, pigtails for intense. Like, it's gonna be great. I put the costume on my dog and she immediately fell over. Like this big, like 50-pound Australian Shepherd. She doesn't care for it.
I don't.
I'm working
I can
on
grab
it.
real quick. Yeah, you need that.
Wow.
Yeah, I did it.
I just need to make sure we have double, you don't have to do it now, we can do it, I can grab it from you maybe when I can.
Okay.
I just need to make sure we have double, convex lenses.
Gotcha. Okay.
Awesome.
You can just kind of put it to the side if you want. You can let somebody else. Let somebody else.
We're doing it again.
Yeah, well, we have to be more ready.
It smells like boiling pineapple.
I was like, this is an interesting smell.
Ick.
That's why I was so tired.
Well, I'm like,
Yeah. So, if you would like to, we have more cans. If you would like to experiment with some ideas that you have about what is happening, you can do that. Is it a time factor? Is it water? Is it how happy you let it get? Is it how fast you submerge it? Can you put it in upside down without tipping it over? And will it work that way? Okay, right? So like, if you just placed it in there.
Normal one.
Maybe think about what if you just heated up the can and flip the can over.
And yeah, so you can try some different.
It also smells like laboratory over here.
Well, it smells like cider over there.
Thank you.
Wait,
Pick it back up.
Did you see all that water that came out of it? What's up with that?
the water went in it.
Okay.
Yeah.
When you guys get a second, try to pick
Because that
one
was
of
way
those
more
cans
than
straight
what
up
was in
after.
Yeah. So do some experiments. You have to flip it upside down. Can you just put it in your normal next to it? Is it how you want it?
Now,
Yeah,
is there
but
water in
that's
there?
what
There was, like, why is there more water than more than 20 milliliters?
He likes the grapefruit kind, which is what that.
So if it got sucked up in there, now start thinking about why did it get sucked up in there, and maybe try to start thinking about expanding on that a little bit more. But yeah, good.
So what if we
So
do?
Aaron and I ended up going to the room on it.
Just drink them all and be like, well, sorry.
And they're just like,
Oh, you're doing one that's
I
empty?
ate a bunch of yesterday.
So one of the two, when you notice when it's
This is not
and you lifted it back out.
just by the way, I'm gonna water it right now.
Is that more
I
water
was
than
like,
you had in it?
no, I also was like,
Okay.
am I that one? What should I do this one?
Suck them in.
I'm scared to just put it in. What if water like that was up? I don't think that's gonna happen. Oops, sorry.
No, you're good.
No, you're
Or
right.
do like
It's just gonna get hot.
we do that
You
one
have to seal it,
where you
or
put
it's not.
Oh, why?
that.
It's a good. Why is that? Why would you say that?
I don't know. It just made sense that you would have to seal it.
Yeah.
What's a vacuum?
There's no air.
No air in it.
There's no air in it.
Starts
Or no air
boiling,
coming in or out of it,
on
so it just-
for like
There's no air coming in and out of it.
That's why I like being a teacher. Answering questions.
Well, think about just maybe keep going with that. You got it.
Yeah.
So is that a dry
Air
one?
produces different, otherwise it'll just.
The dry one is here. So they just did a dry one over here. So are you guys doing a dry one with no water in it?
We have them heating up.
Okay.
What if we do one?
How long did you let yours heat up for? Just the empty one?
A minute.
A minute? So if you guys want to stick with a minute, or you can go longer and see if maybe you get one different from there.
I can't tell if it's real until it's on.
Touch.
Touch it.
And it's very
Oh, it worked.
Let's
It's not as small.
Yeah, it's not as fresh. You want to see how much water's in it?
Yeah.
Pull it up.
Bring up the water.
Yeah. Did I bring up some ice? Yeah, there's ice in there too. It's also still hot. Like you can see, yeah.
What
No,
do you-
actually it's really cold.
What do you see
No,
coming
it's
out?
cold.
What do you see coming out of there?
That's probably steam.
What is
Well,
steam?
water.
Water vapor, okay. Do you think that that's something
I was
important to
also-
account for?
If it's being compressed, that kind of interesting.
And then it's still getting denser.
because do we want to make
You're
one the one that we leave on
you're
for
doing a
a
good job.
while, and the other one like it's
Consider that word compress.
to boil.
Maybe if you're talking about water vapor, maybe that might not be the best word, but you got it. Yeah. You go.
Cloud.
moving really quick. It's different, so it's happening.
Clouds.
Water vapor.
What if you had lots of hot? What if you had lots of hot? It's really fast. Spread out.
That's okay.
Okay, these are ready. Do you wanna do anything
And
else?
then what happens when it gets cold?
Okay, I'm gonna crush it again.
I just like the diesel things.
I know, it's very satisfying. But also the water filter. Yeah, it's like,
They're cold now?
yeah. It gets complete.
Okay, so the water doesn't rush quickly to it.
That's not what it is in.
Right, so this is the, why does the water go up? What? Because it's not gravity.
No, I'm just going into the high chair. Oh wait, maybe you have to like consider coming down, pulling.
So what are
Just
you-
a little one?
What are your thought processes so far? What are you thinking is happening? Best explanation you can give
Like,
right
where
now.
you hear any gas, it's like a higher
I don't even
Even if it's just words that you know, but you're not really sure how they connect. What do you know right now based on what you've been doing just so far?
steam.
Hot reacts to cold.
Okay, hot reacts with cold, good start. How?
Was that the empty chair?
Build off of that. Well, I mean, I think that's an important thing. We're boiling water and then we're dunking it in ice cold water. Why? So obviously temperature seems to be at least something we should consider.
And wait, then a little bit more to put it on lens.
Makes what condenser? What does that mean to
Mine
condense?
is like, yeah.
Like push it together.
What is this if you're talking about now?
Put it in right side up, so I'm gonna
What does?
go,
Heat?
The combination of the heat in that place.
So if we're looking
Okay.
at pressure.
Why? You can help yourself.
Yeah.
I know.
Let's think about this. So think about this then. What were you putting into? Did you notice a can without water and floating?
It did, but just not as much.
Okay. Was it upright or face down?
So we're both.
Or was the whole up or down? Okay, and it still did, it's not as
Was there a
much.
difference in how you submerged them?
You did it with water
Oh, when we.
and it collapsed a lot.
Okay, but did it seem
Right.
to have an effect?
Okay.
If it
So-
was hotter?
What was happening to that? What were you doing to that water in the can that was different from the can that had no water?
yes, so that's up there.
Probably had less.
So now you know that obviously has to be something that has to play into it. So
A lot of people over there.
water is turning into, what do you call that?
I'm going with water.
Water into steam.
Like hot, like water vapor, and then you turn it over.
Well, yeah, I mean,
Ice water.
boiling, right? You're
Yeah.
boiling
Yeah.
water, you're changing it from a water to a water vapor. That's what I was saying.
Pulls the can and what else does it pull?
The water.
Is there any other tests you need to do to make sure that you have your explanation right?
That one has, this is our lot of water and this is our.
And you tested it where you don't put it in upside down?
No, we didn't think
I do the one with the extra hole in it first.
It's a really small. It's
That's okay.
really a thing.
I feel like we should now.
Oh, it took longer. It did take longer. That's supposed to be.
Why did that happen?
I wonder if it's still created the back and I just want to seal that hole first. Ooh, there's chunks in it. What'd you say?
That's probably at the bottom of the recycle bin. It's been there a while. What was that test then?
There's a hole in this can.
Oh,
It's
Poke
very
an extra hole in it.
oh, did you hear that? You wanna try that one too?
Pretty cool.
No, so I don't know where she put it.
Oh, there it is. It's just, but it did, it made it take longer.
The only thing I want you three to talk about now is, while you're doing these, instead of just saying it's causing it to move, right? That's a great, start trying to substitute it words with words. So instead of it, maybe you're saying water. Instead of it, maybe you're saying air. Say the exact same sentences you're saying, and then as a group, plug in the words air and water if that's what you're thinking, and see if you can kind
you can move, because you can imagine like a little diagram
It's
of like
pretty
hot.
cool. It's all like, it's already high level user control too, so it's user in that sense, but yeah, no, I would just want to
I don't think the water was hot.
resources.
Yeah.
Oh, actually, maybe the water just went inside. I don't remember.
Take a few minutes, maybe try to wrap up any experiments you're working on, and then we'll kind of move forward a little bit.
So,
Yes, absolutely.
So then that's happening, because it's
Like
hot
click,
and it's
like-
like cold, like when you blow out the candle, and then the water's moving up it, just like that.
So what's this test gonna be then?
You guys have like something that you've worked on so far? Explanation, what was your explanation so far? Using those air and water words.
I just taught you.
You just learned, you just said your senior year of college, you learned it. Go for it.
So when it's in the, okay, I can't substitute it, it's just in my head.
Okay, you're good, I'll listen.
The water being in the molecule is moving really fast, and then they're
couple seconds, and ice, water,
evaporating.
Mhm.
And then we flip it over, we seal it, and then it condenses into a colder, and so it like shoves it all together, because it condenses, but there's no outlet for it to go anywhere.
So usually, I mean, if you haven't done this or any other class,
Good,
you can
you're
pressure.
spot on.
Oh,
Now,
good.
why is the can
So
actually,
usually
that's
when
the
I
one
see
part
this
you
done in
haven't
classrooms,
necessarily,
they just
like
do
what
this,
caused the can to push
and they
inward?
don't do the
Why did not, for example,
experimentation phase,
why
and
haven't none of the cans blown
experimentation
up,
phase is really
like
important
outward?
because it helps you move it beyond.
Why is it pushing in on itself?
Because the pressure on the outside of her is greater than on the inside.
Yeah, there you go, perfect. So it's put, so the air is trying to go from what to what?
pull water up.
How does an air, how do molecules like move from an area? Constant, high to low, that's diffusion, osmosis, I mean, high to low, that's how things naturally want to go. Yeah, so you just kind of developed your model. Now you can even expand on that and try to come up with a explanation as to why water moved up. Like, why was there more water when you picked it up?
Yeah.
Do you have an explanation?
I know is the candle experiment, like the water,
Mhm.
like the candle.
How's that work then?
It's the same thing.
Yeah, how's that work? You hang on to that thought. You're doing a great job there. Okay. So if I could just kind of redirect your attention up here, just for a few minutes. Again, because just kind of for time constraint purposes, maybe we can't do maybe everything you would do in your classroom, or maybe everything that I would, but I think what's really important here is that we now start coming back to examine our initial models with a little bit more, you have more of a concrete idea of what's happening, and incorporate some evidence to maybe refine your model. So here's some things I'd like you to consider in your groups. There are 3 prompts when you're revising your model, and these came straight out of the textbook as well. So again, some really great examples in there. I want you to do consider 3 things. Maybe there's somewhere in your initial model where you want to add something. So maybe, a way to think about it is we think that some activity that you have in your class to support this topic, right? So for us today, it's going to be just a reading, right? It's just a PDF reading document. But maybe you have, Alice had a link to a simulation. There's a simulation that goes along with it. Maybe you have students explore that and incorporate evidence from those activities to add to the model. Do you see how that prompt works? So I'm explicitly asking you to maybe think about, we think that the reading supports part of our model, but we want to add blank to make it more accurate. Think about about things you might want to revise. So after the reading, is there something you want to change? Or after the reading, is there something you want to remove or find out more about because you're not really sure if it belongs there, or if it does, it seems to be missing something. So at least, a bare minimum that I'm asking for your group is that you identify at least 2 places on your initial model after you read this reading here. Identify at least 2 places on your model, state evidence from the reading, and say why it supports the relationships you have drawn. So for example, if your group is adding something, state why you're adding it. What from the reading told you to add it to your model? That's what I'm asking you to do as a group, and do that for 2 different places in the model. You can do more, but at least 2. Does that make sense? If you had more time, you could click on the simulation. I don't think we will today, but that's an extra resource available. There's tons of stuff you can use to teach this. And then these are those conventions if you decided to follow them. Any kind of air particle or maybe water molecules, whatever, you can represent by dots, use arrows, but it's up to you to decide how you want to revise that final model. Cool, so you can access that reading now. It's on Moodle in the PowerPoint. I think now we're at a good point where you can use your laptops and have that reading pulled up. And again, try to identify 2 places based on that reading. It's not a really long reading, but maybe use the headings to focus in on sections that your explanations seem to be missing based on what we were talking about while you were doing the demo. Focus on those sections, and then it won't be as much reading. And this works best if you talk about the reading with members in your group, especially if the terms are unfamiliar to you. Yeah, it should.
Is it this?
It's the bottom one, yeah.
Yeah.
It's in this. Refresh this. Is it? It's not. Oh, there it is.
We're just adding things.
Add to, revise, or remove. I think the revision part would be really cool to focus on too. Maybe your model was incomplete or just partial. So
If you would just do what she did.
think about
Yeah.
when
Oh,
you
yeah,
were,
because these two are gonna be the same.
when did you use, when did temperature play a role
So, like,
in your model? When did you consider temperature? At what points in your experiment?
Is this happening during it, and what's happening on the inside, is that the?
Okay, so let's start there, since that seems to be kind of the first step. You poured water into the can, right? So what part of your model do you think that would fall in? Just filling up the tank with water?
Monitor the air is the same.
That's probably just that room temperature water, right? You start heating it, and what did you notice happen out in your model tank? And how did you know that? Okay, so water turned to what?
Right.
Gas or water vapor, okay. Now, the during crushing phase, are you guys revising this at all?
We will, yeah.
Okay. So this is where I think you'll have to start considering where temperature comes into play. Why did we even have you heat up water instead of just doing can, or instead of just room temperature can? So then, do you think that temperature caused the implosion, or was it something else happening that caused it? The temperature influences that.
Yeah, right, like,
Pressure,
to kind of together showing that they're like,
what caused there to be a pressure?
How so?
sure,
Because
that's how they look in the model too, so
there
it
is
should make
the
sense.
water and vapor molecules are like bouncing around everywhere, and there were a lot of them. But they were able to escape through water, and they were trapped.
Right. Well, and when that water that you're boiling turns into water vapor, you were putting it upside down in a container of cold water, right? So what is that water vapor that you just created? What does it do? Does it just keep turning into water vapor when you reduce that
The
temperature?
blends are
quickly?
just the same.
It's just the same throughout.
What happens to it?
Air, so it just stays constant.
Yeah, it's changing.
Condenses, right? So because you're cooling it down really quickly. So that is kind of where the temperature might come to play is the during phase, because it causes that pressure difference. And then the crushing part would be the actual
So we're going
pressure difference, which is what you told me. So that's where, I think where your group was maybe struggling was temperature didn't cause the implosion, but it influenced the
Are we doing these two the way they are?
Yeah.
Does that make sense? I would just maybe be careful with that, but I think during and before is where it counts most, and maybe towards the after part,
I mean,
air
it makes
pressure,
sense, like,
which was
if this was
influenced by the
already
temperature.
But this is like before it's getting crushed, like it's changing the pressure, and then like this one's like.
You need to draw.
Yeah, like maybe just kind of start sketching, it, maybe just one place
Because it was.
where you would change something in that diagram. You can add to it, that's fine. Like they just kind of, I think, included something or. Actually, for the sake of time, we might not need to worry about that too much. So yeah, you're okay. So this is just kind of you may or may not decide how you would want to present this kind of summary to your students, but just to give you some context into what your desired outcomes would be, and maybe you would go about this type of activity differently. Maybe you would plan, several different structured activities in the middle. Maybe you leave it very open-ended. I don't know. But just kind of giving you a frame of reference of what you would expect. So the before part, so the pressure inside the can and outside of the can, they're the same. That's why the can was open. Air or particles can move freely in and out. It's not air being stuck in or air staying out. It's just moving freely. And so we call it equilibrium. What I think is cool about this activity is usually with chemistry, they will have already taken like biology or physical science or something like that, is maybe where you discuss this, and so you can start relating to concepts that they've been exposed to, I think, previously. This is still true when water is being heated and the hole is not sealed off. Even though you're creating water vapor, it's still free to move in and out because it's nothing sealing it off. So that air pressure is the same on the outside as it is on the inside. We call that equilibrium. During, that water turns to water vapor through the heat. And what that water vapor does is it actually displaces or pushes out the rest of that air. And what you were doing is you were taking the can, you were flipping it upside down, sealing it off, and when that water vapor cooled, it condensed. As things cool down, particles move slower, not faster, so they started colliding. Fewer molecules started colliding, which caused a decreased pressure in the can. We know that things like to move from high to low, and so after what happened, since the pressure inside the can was less than outside, air tried to move in. But if your top was sealed off, air couldn't get in there, right? So it just starts pushing on the outside of the can, and it does that to reduce the volume of the can until the pressures are equal. So it can't actually push air in, so to kind of compensate for that, it just reduces the volume of the container to make the pressures the same. And so I think that that's an interesting concept there. That kind of goes into, I guess, really gas laws pretty well, the relationship of pressure, volume, temperature, all of those things. So this can really